Passwords suck, but passwords on mobile are even more painful. Hello, my name is Maya Ben-Ari, and I'm a product manager on the Android platform. Let me start with a quick story. I recently landed at the San Francisco airport after an exhausting 12 hours flight. At the baggage claim, I had an idea. I can order food with my phone, so it would be waiting for me when I got home. I quickly downloaded an app and found the perfect Chinese noodle dish. I was about to submit an order, but then I couldn't remember my password. I knew there would be no food for me when I got home. I wish it would just be easier, and with the new fingerprint support, we're going to change that. With Android M, we're adding native fingerprint support for enrollment and device unlock. We believe that your device should stay secure, but we'd like to provide you the best user experience without getting in your way. In addition, we're introducing new APIs for Fingerprint and Confirm Credential to accelerate payments and sign-in operations. These APIs will allow you to utilize your fingerprint sensor if one exists on the device. In the Google Play Store, if a user has a registered finger on her device, she can choose to use it to confirm her purchases. When she wants to buy a song, she can simply tap her finger on the sensor to complete the purchase. This is all made possible with the new Fingerprint Manager class. This simple API allows the app to authenticate a user using his or her fingerprint. The app receives an authentication callback from the sensor once a finger has been detected. The API will authenticate the user each time the app requests an authentication call. The API utilizes key store to create and use cryptographic keys. Fingerprint Manager gives full control of the UI to app developers. It allows apps to natively integrate fingerprint into their flow. In this example, the target app is using the fingerprint APIs to confirm users' online purchases. A user can add items to his cart, and when he's ready to check out, he can confirm using his finger. For consistency across app, we recommend using the Android fingerprint icon. To summarize, our fingerprint APIs can be used to accelerate online payments and sign-in operations. It authenticates the user each time the app requests to do so while providing the app developer full control over the UI. Fingerprint Manager is great for authenticating per transaction, but what if you want to know how recently the user has unlocked his phone? With our new Confirm Credential API, you can leverage the user's lock screen for authenticating the user. Here, I have a phone which has been modified to add a fingerprint sensor. To pay in store with Android Pay, the next generation of mobile payments, I'll tap my phone on the terminal. The app then checks when I last unlocked my phone. If I unlocked in the last 5 minutes, my payment is considered secure and I can continue with my purchase. However, if more than 5 minutes passed since I last unlocked, the app is not sure whether I'm still around my device and will prompt to authenticate. Only after I solve my lock screen challenge, I can complete my purchase. What is great is that Confirm Credential integrated with Android Pay authenticates me only when it needs to. Confirm Credential can be further extended from device unlocking to application locking. By leveraging the user's lock screen combined with the timeout policy since user last unlocked, the app can protect the user's sensitive information, such as bank details or credit information. For example, Credit Karma, a credit and financial management app, provides the user a choice to protect the app with her lock screen. Next time she opens the app after solving her lock screen challenge, she can quickly log into the app. To use Confirm Credential, call Confirm Device Credential Intent in KeyGuard Manager. With Confirm Credential, an app can create a cryptographic key and tie it to the device lock screen with a timeout policy. For example, did the user unlock the device in the last 10 minutes? Note that developers can choose what timeout they wish to require. When the app wants to authenticate the user, it should first try to use the cryptographic key. If that fails, the app should prompt the user to authenticate using the Confirm Credential API. This will automatically unlock the cryptographic key. The key access timeouts are synced across the system. This ensures that different apps prompt to authenticate only when needed. To summarize, Confirm Credential allows an app to create cryptographic keys and tie those to lock screen. It allows developers to specify a timeout policy for key access while syncing timeouts across the system. Our new APIs provide apps both convenience and security. It is up to the app developer to decide which solution fits him or her best. For example, while the Fingerprint APIs might be better for in-app purchases, the Confirm Credential might be better for in-store purchases or app-specific login. To try out the APIs, please check out these resources which will walk you through getting set up. And for the next time, I hope someone can make it easier for me to order food without entering any password. Thank you for watching.